In this lesson in the series on the biology of learning strategies, we'll take a look at how retrieval strength and storage strength change over time as we engage in typical study practices. So here we are, we're going to start with study session number 1, and we will increase retrieval strength. Our working memory systems are processing the information, we're understanding what we're reading or watching. And if we just momentarily put the book down, we'll be able to retrieve information about what we just read. So we have high retrieval strength. The problem is students mistake retrieval strength for storage strength. Then they stop studying and they don't retest. So when we have high retrieval strength, we may be tempted to think that that's an indication that we have high storage strength, but in fact, we may have only made modest gains in storage strength. This, after all, is the first study session. Now, we call this misconception 1. We think we know it, we know the information because we can easily retrieve the information during the study sessions. But we can easily retrieve it because the retrieval strength is high due to the working memory boost. We don't have high retrieval strength due to high storage strength. Rather, we have high retrieval strength due to the working memory boost. Because we have low storage strength, it means that we will be forgetting the information quickly. And again, it's as if students underestimate how fast they will forget because they're mistaking high retrieval strength for high storage strength. Now, if we continue our study session, and we're enjoying the high retrieval strength here, we face the counterintuitive relationship that Bjork and colleagues argue for. And that's this idea that when retrieval strength is high, further study becomes less valuable. So as we continue to study under conditions of high retrieval strength, notice the storage strength is not increasing very much. And one hypothesis for why we don't show increases in storage strength here when we study under conditions of high retrieval strength is that we may have already made the maximum increases in synaptic strength in the relevant synapses. So further study has little benefit because we've already strengthened the relevant synapses to some kind of maximum level. We've reached the limit of synaptic plasticity. Now, when we finish our study session in the evening and then we go to sleep, a couple of interesting things happen. First of all, sleep results in lower retrieval strength the next day due to the delay. So the working memory boost is going to be gone. But also, consolidation processes occur during sleep, thus increasing storage strength. So two counteracting processes are happening. Sleep is a delay, and that will reduce the retrieval strength. But in addition, storage strength is increasing due to the consolidation processes that are happening during sleep. Now, the next day, if we revisit and we do study session number 2, we have a situation where we have lower retrieval strength. So spacing out study sessions, like having sleep in between study sessions, creates lower retrieval strength upon restudy. And spaced study sessions will be able to increase storage strength more than extending the original study session. The effects of consolidation processes can accumulate if there is a delay between study sessions. So it's really a strategic move to create delays in the study session because we purposely want to reduce the retrieval strength. When retrieval strength is low, then we have the opportunity to make gains in the storage strength. So increases in storage strength require multiple consolidation events, which must happen over time, preferably with episodes of sleep intermixed. Spaced study sessions lower retrieval strength and set up repeated opportunities for consolidation. And because we have higher storage strength then, that means that we're going to have slower forgetting. Notice the slope of this line here is more gradual compared to after the first study session. There was a steep slope here, a steep forgetting slope. Because we have increased storage strength with a second study session, we now have a more gradual forgetting slope here. Now, by definition, cramming is a single study episode just prior to an assessment. As such, it cannot lead to large increases in storage strength because the brain has not gone through repeated retrievals and reconsolidations, which are the keys to long-term retention of information. The lower storage strength after cramming means a higher rate of forgetting. In summary, then, if we want to retain access to information over the long term, then we need to take advantage of sleep. Sleep is an important element of any good study strategy because important memory consolidation events occur during sleep. We also want to use repeated study sessions, and we want to space them out. By spacing out the study sessions, we are going to create conditions of low retrieval strength. And that may help the brain set up repeated consolidation events where we can make a memory stronger and stronger. In addition, we want to use retrieval practice. Studies show that this is superior to simply reviewing notes or rereading information. And it may well be that using retrieval practice, it engages the memory retrieval systems in a way that triggers, again, the consolidation process better than simply reviewing notes or rereading information.